who are young and keen in the area of sheep breeding and sheep genetics in particular, fronting this morning. He's not quite as young, but we can still apply the tag gun to our next speaker. And the reason I know he's not quite as young because he was a year ahead of me at uni. So Andrew Swan and I go back to rural science days a few years ago, and I won't tell you how far back that was because that'd be dobbing myself in as well. But Andrew completed his PhD with the Animal Genetics and Breeding Unit and then moved on to work for CSIRO for quite a number of years, based at the Chiswick Research Station just out of Armidale, and certainly was focused very heavily on sheep work during his career there. Since leaving CSIRO, he's come back into the fold at AGBU and has been working primarily, I guess, on the merino-focused aspects of the work, and more recently on sheep object and the index development component. And that's what Andrew is going to speak with us about this morning, about integrating eating quality into the index development work that Daniel alluded to yesterday. So this will continue on from those points of Daniel. So if you could please welcome Andrew to the podium, and he'll speak with us now on breeding to improve meat eating quality. Thank you, Andrew.
Thanks, Richard, and you haven't changed a bit. So yesterday we heard quite a bit about the antagonism, if you like, between eating quality and lean meat yield. And today I'm going to tell you about some work I've been doing to put eating quality into a breeding objective context and be able to have indexes on them, and so that we can partially address that antagonism. So in this room, I don't really have to tell everybody what a success genetic progress in the meat sheep industry has been, but over a long period of time we've had gains in growth rate and lean meat yield, and that's what this graph here shows, the trend in Carcass Plus since 1990. You can see long-term sustained gains in those traits. And part of the reason for that is that Carcass Plus is really it's a quite simple breeding objective based on a few traits, and those traits are accurately assessed. But if the industry wants to remain competitive, we also need to think about eating quality. And as I said before, and we heard yesterday, there's the potential for the antagonism between growth and lean, what we're selecting for at the moment, what we have been selecting for, versus eating quality. So if we're going to put eating quality into an index, the first thing we have to do is to be able to work out what the economic value of it is. And to do that, I use three pieces there's three pieces to the jigsaw. The first one is up here, that the Sheep CRC did a large consumer eating quality trial in 2011 and 12. So that involved taking samples from around about 1,500 animals out of the information nucleus flock, and samples from those animals were eaten by consumers, and they then scored those samples for various eating quality attributes, tenderness, juiciness, flavour, overall liking, and they scored them on a 100-point scale. So we have that data on the information nucleus flock. So the next thing is that those eating quality scores transpose on top of the MSA retail grading system. So if you you've got a higher eating quality score, higher MSA retail grade. And then the final piece of the jigsaw is that the consumers involved in these trials, at the conclusion of them, completed willingness to pay surveys, and so that gives us some information on price and how that relates to our eating quality scores. So what was observed was that there was a large amount of variation between animals in eating quality score. That's represented by this bell-shaped curve. The sorts of differences from the top to the bottom, would be say around 40 to 50 points on those MSA score individual traits. And within that distribution, we then have cut-off points between the different MSA grades. So you can see that here in this particular example, the majority of animals are graded 3-star, but we also have a proportion that are ungraded and some that are higher graded and so on. So if we could increase eating quality score by whatever means, that would mean that we would get, obviously, an increase in the proportion of median higher MSA grades, and that would translate into an increase in value. To put some numbers on that, taking the data that we have from that trial, if we increase the topside eating quality score, they had 2 sites in this trial. It's topside and loin, two cuts of the carcass, I mean. And so if we increase eating quality score by 1 unit, what happens is that from the red to the blue, we have less ungraded meat and we have more grade 3 and 4. And now from our willingness to pay data, we know that consumers value quality and that relative to a grade 3, if meat was ungraded, people would be prepared to pay only half as much for it. Going from 3 to 4, they would be prepared to pay half as much again, and for the highest grade, twice as much as grade 3. So putting those 2 bits of information together and working off market values for carcass prices that people receive, an increase in 1 score translates into an increase in carcass price of 15 cents per kilogram. That's off a base of $4.50 at the moment. So that would be what, in theory, a lamb producer would receive if there was supply chain feedback. And that 15 cents per kilo, when we put it into a breeding objective context, gives us an economic value for eating quality score. So that's on the 100-point scale of $3.21 per ewe. So that's the economic value for eating quality. Then we have to put it into an objective with all the traits that affect profit. So we need to have economic values for all those traits as well. The other things that we need, really importantly, are genetic parameters for eating quality. So the first one there is that eating quality is hopefully heritable, and that's the way it turned out from that eating quality trial. There are different traits that I explained and different sites, and across the range of traits and sites, cuts I mean, the heritabilities were in the range 0.2 to 0.3, so indicating that we can make genetic improvement in eating quality. But we're hardly likely to actually measure it very often, so the way to control it in an index is going to be through genetic correlations with other traits. So those genetic correlations become really important. It's very, I can't really stress enough the importance of getting good genetic correlations between eating quality and the traits that it's possible to select on. Okay, so in putting this together, I actually worked out a new index for, we're looking at terminal sires at the moment, so it's a new terminal sire index. And what you'll notice that compared to the current Carcass Plus or Lamplan 2020 index is that apart from sale weight here, all of the economic traits are actually based on the carcass. So we can do that now because in the information nucleus block, we have a lot of data on those traits, as Graham was talking about yesterday. And so that we now have accurate genetic parameters and indeed genomic predictions, RBVs, that are available for selection. So you can see that eating quality and lean meat yield, they contribute. What I've done here too is that these percentages are just the economic values scaled to the amount of variation that is present in each trait. It's not actually the genetic outcomes at the moment, it's just so that I can put in relative terms. And you can see that they're not dominating, but they are still important traits. These are some of the genetic correlations, so just for eating quality and lean meat yield. And you can see down the bottom, this is where our problem is that we were talking about yesterday, the antagonism between the traits. The two traits themselves, lean meat yield, the two objective traits, lean meat yield and eating quality, they're negatively correlated, but it's not. It didn't turn out to be really, really bad. Just a little bit bad. What is bad is the correlations between for intramuscular fat and shear force with both eating quality and lean meat yield. You can see that they're in opposite directions. So for eating quality, we would want higher intramuscular fat and lower shear force, whereas it's the other way around, and quite strongly so for lean meat yield. So that's really where our problem comes from, because it's these traits that we have RBVs for, and they will contribute heavily in the index to both of these traits, and in the wrong directions. Okay, so having put the index together in economic terms and then estimated the genetic parameters, what we can then go on and do is calculate how much genetic gain we can make. So I've done those calculations for 3 different indexes. So starting off here, the current Carcass Plus index to give us a baseline, and then LMYEQ I've called the new eating quality index, so that's based on our carcass traits plus eating quality. And then I made a third index which included extra emphasis on IMF to address that particular problem. You'll see the results in a minute. So 3 indexes, and then I've got 2 different sets of information available for the animals at selection. So first one is just having base traits. That's body weight, muscle and fat, just measured on live animals, just what people have done in the past and currently. And the second one is adding to those base traits genomic predictions of carcass traits. So those are the RBVs that people are getting if they're doing genomic testing at the moment. So 6 scenarios all up, and then I calculate the genetic gain assuming basically the population structure that's represented by the land plan terminal sire database. So here are the responses for yield and eating quality. You can see that to start with, Carcass Plus is doing a reasonable job at improving eating lean meat yield, but it does definitely lead to a reduction in eating quality. With our new index, just the eating quality index, we actually get more on lean meat yield. Part of that's due to lean meat yield being directly in the index, and partly because there's actually a negative economic value on fat, which we'll see more about in a minute. But what we do see over here is with this index, eating quality is getting better, but it's still actually negative. I should have said that that the red bars here are just when you measure base traits, and the blue bars are the amount of response that you get when you also have genomic predictions. So in the case of this new index, we do better on eating quality if we actually have genomic predictions. And we're getting quite close to 0. When I put IMF in the index, lean meat yield basically disappeared. It actually went negative if just for the base traits, but still a little bit positive if I've got genomic information. But eating quality is now positive, particularly so for when you have genomic information. So this is the story now for IMF and shear force. You can see that Carcass Plus and the new eating quality index both are predicted to lose intramuscular fat and to increase shear force, which is where we don't want to go. So that was why I added the third option of the IMF index, just to get some positive pressure on IMF, and that's what's actually happened there. But it works better with genomic information. We get more IMF, and also shear force going now. That's the only option where shear force is going down. These are the results for growth, muscle and fat, and you might remember that the body weight was actually a question yesterday. None of these indexes, all of these indexes produce large gains in body weight. And in fact, the two new indexes are actually slightly better than Carcass Plus. For eye muscle, Carcass Plus is the best, but we lose about half of it for the eating quality index and a little bit more when we add IMF in. Fat depth is interesting. Carcass Plus, we predict that with the genetic parameters that we have at the moment that it would go up. The new index, I said before, but it actually has a negative economic value on fat, and so we end up with a reduction in fat there, and that was actually helping lean meat yield to go up on the first of these response slides. When I add IMF into the equation, though, it's still a negative economic value on fat, but you can see that how it actually gets IMF, especially when you only have base traits available, is that it actually increases subcutaneous fat. Not quite so dramatic for when you have genomic information. So to summarise all those, compared to the current Carcass Plus index, our eating quality index would tend to select animals that they have faster growth rates, they have lower eye muscle depths, but still they're still positive. But I didn't give it a green arrow, I gave it an orange one. Has negative fat depth. Now people can argue about which direction they want fat to go in, but in this particular example I had a negative economic value on fat. Has higher lean meat yield and improved eating quality, but it's still negative. But the problem there is that both indexes still have reduced IMF and higher shear force. When I add emphasis on IMF, still getting high growth rates, got lower eye muscle depth, but they're still actually positive. Got increased fat depth, especially without genomics. So I've said that's a bad thing because the economic value was negative. Lower response to lean meat yield, but still positive, and we now have the positive response in eating quality and favourable responses in shear force and IMF. But with that IMF index, I think it's pretty important to recognise that you really do need genomic information to get the best results. So these are just looking at the economic gains, overall economic gains for those indexes, relative to what I call the optimum economic index, which is that eating quality index with genomics. So what you can see there is for that index, genomics gives you an extra 10% in economic gain. But compared to the Carcass Plus index that people are using, that people have used in the past, this new index with genomics would be about 20% better. Going to the IMF index, putting IMF in, you actually lose 10% of the economic gain that was the loss of lean meat yield. That's if you have genomics. If you don't have genomic information, this index really is much lower in terms of economic gain compared to the optimum one. So perhaps not realistic to use that one. Okay, so there's plenty of questions there, I suppose, and so what might you do? Well, if you are worried about eating quality, then I think that you do need an eating quality index because of this antagonism that we have. It certainly works best with genomic testing, and also some extra pressure on IMF might be desirable. Not quite sure what to do about if you don't have genomic information. It's certainly difficult to improve eating quality without losing lean meat yield and without having IMF and shear force go in the wrong direction. And it's, as I said before, this IMF index is pretty inefficient unless you're doing genomic testing to go with it. So it seems to me that we might actually need several different indexes for different situations, which might apply to different markets and breeds, and whether or not you've got genomic testing available. So I've actually tried to summarise that on this slide, where if we look at the directions for eating quality on the x-axis and lean meat yield on the y, this curve here basically shows you it's like a frontier of the maximum possible change for a certain balance between the traits. So where we'd like to be is obviously over here with both traits improving, but what we can see is that's where Carcass Plus is. It's increasing lean meat yield, but at the expense of eating quality. We could actually make an index to push lean meat yield really hard, and it would go even better than Carcass Plus, but we'd still be getting the loss in eating quality. Our new eating quality index is here, still pretty good for lean meat yield, and eating quality is not, we're not losing too much. This is if we've got genomic information, and down here is where the IMF index that I presented ends up, but you can see there's a range of space in between there where you could actually operate. So this is pretty new work, really. I've only been doing this for the last 3 months or so. A fair bit to go, but we're still working on some model refinements and checking a few things out on the calculation of the economic values. But really importantly, we need to get these genetic parameters as precise as we can, and that's really underpinned by an ongoing reference population. All of those responses are a function of the genetic parameters we estimate, so you can appreciate the importance of getting accurate genetic parameters to do this sort of work. After that, we need to start validating it on industry animals, and given the importance of genomics in this story, we want to be doing that from a new multi-trait genomic analysis across the whole terminal sire database, and we've been working on that at the same time. We have the computational side of it sorted out pretty well now, so within the next 1 or 2 months I'll be turning my attention to applying the indexes to the results from that analysis so that we can have a look at how the index actually performs in real life as opposed to just making those predictions. And then the final point is that clearly we need industry consultation to work out what the appropriate balance between yield and eating quality is, and also looking back at how the rankings look on animals compared to what people are used to. This is my last slide. Just to sum up, I mean, as we all know, I mean, Lampland really has been a great success story in developing a product that's been demanded by consumers, with more meat with less fat. But all along, I think people have recognised that you needed to be careful to avoid making animals too lean and creating problems with eating quality. But with this sort of work, I think that we now have the tools and the data, importantly the data, to manage carcass composition and eating quality together. We will find rams with the right combination of traits eventually, but initially they will be rare. And just finally, I just would like to acknowledge that this work's underpinned by a really big effort in meat science and genetic programs of the Sheep CRC, and Dave Pethick and Tony Pleasance have helped me with the derivation of the economic values. Thank you.
Thank you, Andrew. Do we have a couple of questions from the floor? First one from Barry. Thank you.
One of the questions we have, and part of a young sire group, is that as you hone down on specific traits like your eating qualities and so on, we actually narrow down the selection opportunities we have for young sires with some variation in their genetics, from a wider field. Do you, when you look at this, Andrew, do you see any solution to that?
I'm not quite sure I understood the question, but I don't think that'll really become clear, well, not to me, until I start actually calculating the indexes on animals. Could you maybe say that again? Sorry, I'm a bit slow.
Well, part of our problem is because, particularly in young sire groups, where we sort of chase high EBVs and indexes for animals, we can come down to a small number of sires. And particularly when you're looking at lean meat yield, shear force and so on, and their negative correlation, there's only a few sires that have complementary figures. Yeah. And that, to us, is, can narrow our field of sire selection even further.
Yeah. I think that what you're observing is the reality of those genetic correlations, and that life is more difficult when you're trying to balance these traits. Don't have an easy solution for that.
Yeah, Andrew, Lockie Day here. You put an economic value of 15 cents a kilo carcass weight. Have you tried a higher value, say 25 cents carcass weight in the indexes, and if so, did it have any effect on them?
For the eating quality?
Yeah, you put 15 cent premium there. If you say put a different value on that, did that change how the indexes worked?
Yes, it's very similar to. I have done that. I've in fact gone up to doubling the economic value, and it's very similar to the option I presented for IMF. So the reason I presented IMF is that I thought it was worthwhile putting some direct emphasis on IMF in this situation. But those options are there. So what they do is they just wind back lean meat yield and increase eating quality. But not, it's actually good if you also want to look at IMF. If you're also worried about IMF, it's also good to have some direct pressure on that.
Troy Fisher, Andrew, my question's about the assumptions in the genomic predictions. So is that measuring all animals for genomics, or the 20% that Lamplan talk about, or?
Yeah, that's like doing all males.
So that's testing all males?
Yeah. It's that's a these are approximations of what might happen when we start having the single step analysis as well, because I think more information will flow onto animals that are not genotyped. The half sibs of some of the ones that you have genotyped. So I think you'll still be able to do less genotype, like the 20% of the drop or whatever, if you choose them carefully, so that the information spreads across all of your offspring.
Thanks, Andrew. To bring us to a close, I might get you to just address the first question on the second line there.
Yeah, so the second line, dressing percent, is 22% of the economic value. Sort of scaled to the amount of variation it was. Dressing percent improves, sort of similar outcomes to lean meat yield. So if lean meat yield was increasing by 1%, then so would dressing percent. So that's the answer on that. It does improve. Is there a possibility? I've started off with the terminal sire because this was where it was most relevant, but it would be straightforward to do the same thing for merinos and maternals. So yes, definitely could be done.
Okay, thank you, Andrew. We bring this to a close, and if you could show your appreciation to Andrew for his presentation this morning. Thank you. We'll now break for morning tea, which will be straight out the back as you go out the door. We'll have about 20 minutes, so we'll be giving you a call up at at about 5 to 11 to come back in and resume the final session. Thank you.